Hi, this is Alexander. In this video, I'll demonstrate C2v, a fully automatic C2v source code translator that has just been released. We'll run some simple examples and then translate the entire original Doom, the legendary shooter, the first 3D game. Let's start. First, we have a simple C program that prints prime numbers. It's a small one, but it has some of the most widely used language features: function definitions, control flow via for loops and if conditions, various expressions, etc. We can translate the C file to V by simply running v translate primes.c. It'll create primes v with the following contents. This is a valid V program, and running it will give us the same result. Let's try it. This code is pretty similar to the original, but you can notice one major difference. C allows one statement code blocks without brackets, and V doesn't. So in the translated code, all blocks are explicitly marked with brackets. C2v also successfully converts C's bool type to V's bool. C2v also has a wrapper generation mode. For many projects, it would make more sense not to translate the entire C code base, but just to generate V wrappers on top of C APIs. For example, let's say you have some complicated crypto or networking library in C with lots of functions and types, and you don't want to manually type their definitions in V. Well, for this, you can use the C2v wrapper mode. We have a simple file, users api.h, and by running vtranslate wrapper users api.h, we get users api.v with just the function definitions. C doesn't have modules, so in most C libraries, all functions start with the same prefix, users API in this case, the name of the virtual module. C2v helpfully strips those prefixes and generates nice, clean wrapper functions that can be called with a simple users api.createUser instead of a longer users api.users API createUser. Perhaps in the future, C2v will translate C strings, char pointers to V strings as well. Alright, this works and it's nice, but these are very trivial examples. Let's try something a lot more fun, like the Doom game. We think it's very important to have large functioning examples to demonstrate the power of the tools, but also to have something to test via CI to avoid regressions. During V's release, we had lots of various examples, and now for C2v, we have Doom. This is the primary test of C2v. Doom is a very complex project that uses some really tricky elements of the C language, and making sure C2v can always handle Doom not only serves as a good C2v test, but also as a test of the V compiler itself, since it can run entire Doom in pure V. So we've downloaded the Doom source, and now let's build it just to make sure everything works. The original 1997 open source release doesn't work nicely on modern operating systems, so the community has been working on different forks. I'll be using Chocolate Doom. It's one of the most popular forks, and its goal is to be as close to the original as possible. They even keep the original bugs. The main difference in this fork is using SDL for cross-platform rendering, so we'll need to install SDL2 before we can build it. On this machine, SDL2 is already installed. The great thing about Doom is that it has a very simple structure and is easy to build. It's just a bunch of C files that are compiled into object files and are later linked into a single executable. So building it is very trivial. We just run cmake. Well, first we have to do cd doom chocolate doom, then run cmake dot to generate make files. Now we just have to run make. We're also going to need a freely distributed shareware and doom1.wed with game resources and the first 3 levels. Let's try to run the compiled game. Great, as expected, it all works. So now let's try to translate this to V and try to build that. In the previous example, we translated a single file, and this time we'll translate an entire directory. V translate source doom. So this creates a new directory, source/doom/doomv, and we can use any name we want, by the way. There is a C2v configuration file. So let's have a look what's in there. It has a bunch of files translated from C2v. We can open any file, for example ggame.c, and verify that it is indeed Doom code translated from C2v. It has also been nicely formatted by VFMT. Now let's build it. I'll explain what we have in the shell script a bit later, but first let's run the translate code. The script compiles everything into a single binary. As you can see, everything works. We have the music, we can actually play the game, walk around, shoot enemies. There's a slight rendering bug at the bottom, but it can be cleaned up by pressing tab twice and forcing a re-render. That's a bug somewhere in C2v. It has just been released and needs some fixes. Now let's look at the shell script and see how we actually build the V translation of Doom. C2v doesn't understand makefiles yet, so we have to do things manually. In the future, making such scripts won't be necessary. Since Doom uses C libraries like TextScreen, PC Sound, and OPL, and we're only translating Doom itself, we need to build Doom.o and then link it with the rest of object files. So the first line compiles all V files in the Doom.v directory into a single Doom.o object file. Translated tells V that the code was translated from C, so the compiler is less strict. For example, it allows using the I++ increment as an expression, and in V it always must be a statement. In the future, C2v will be able to translate such C expressions into valid V code, and -translated will be removed entirely. After generating Doom.o, we can compile the entire project. The second line links it with the rest of the object files. So here we have the shared library used by other games in the Chocolate Doom project, Hexen, Heretic, and Strife, then TextScreen, PC Sound, and OPL. In the near future, we'll also translate all these C libraries Doom depends on, and this shell script and interacting with the C compiler won't be needed at all. The entire project will be runnable with a simple v translate Doom and then just v dot. One other thing I wanted to do is to show you that it actually is V code we're running. So let's modify something. Let's go to penemy.v and modify the pMove function. This function is called every time an enemy is moving. And let's just set a simple print here. Now let's rebuild it. And let's run it. Let's find an enemy. And there we go. As expected, the message is being printed every time an enemy moves. So, we translated the entire project, but sometimes it may be better to do more gradual transition from C2V. For example, if you want to move your project from C2V, you might prefer doing it slowly and carefully, file by file. After each file migration, you can run tests and see if your application runs correctly. You can do that with C2V. All you need to do is just to translate a single file, generate an object file, and replace your current C object file with a new V object file. We can do this with Doom too. In fact, that's how we made the entire thing work. We were doing it for every single file, one by one, fixing compilation errors, bugs in C2V, and runtime bugs. So let's run make clean to clean everything up. And now let's build the original version of Doom. This is the version without any changes. We just want to run it to make sure that nothing is printed in pNME-C. Yep, it's all clean. So now let's actually modify pNME.C and add a simple print to the same function. Now we're going to translate just this one file from pNME.c to pNME.v, and then use v to compile pNME.o. Now we just have to copy our version of pNME.c.o to the cmakefiles directory. Let's just verify that we have the correct files here. So as you can see, the time is a bit different because it was generated later, 1 minute later. And now let's try to rebuild Doom. Let's run it. And yeah, the moment we meet the enemy, we get our hello from C2V message. It works. It's actually amazing how well it all works, considering that there have been two translation processes, from C2V via C2V, and then from V back to C again via the V compiler. In fact, we can actually look at the generated C code after all the translation and compare it to the original. It's very clean and barely changed. So both C2V and V generate clean, human-readable code. As you can see, the comments and C defines are missing right now, and that's obviously something very nice to have, so they will be translated as well. C2V has just been released, and it's going to mature with the help of the community. With bug fixes and new C features supported, it should support the entire C standard soon. Luckily, C is a relatively small language. And any kind of software written in C will be translatable to V fully automatically. I will also be publishing the same demo with SQLite and Quake translations. This is a huge milestone for V, and this gives V developers access to large amounts of software written in C. We're very excited about this release. Thank you for watching.